Okay, in this first problem, Jack recently purchased a computer for $600 and a camera for $172. For the population of the type of computer he bought, the mean price was $675 with a standard deviation of 50. For the population of the type of camera he bought, the mean price was $220 with a standard deviation of 15. Assumes that the distribution of prices for each population was bell-shaped or mound-shaped. Which purchase was the better deal? And then there's a hint there to check the z-scores. First thing, I made some diagrams to illustrate both distributions. The information given was that they're both mound-shaped distributions. So I made the histograms, the models here mound-shaped. Notice that the variation or the standard deviation of the computer is larger than the variation of the camera, so I made that distribution a little wider, indicating that variation number was larger than that of the camera. The question is trying to compare the two situations, the two purchases, and try to determine which was the better deal. And in using z-scores to do that, I'm going to calculate the z-score of the $600 price that Jack paid for the computer. So take that data value of 600 and subtract 675, the mean, and divide by the standard deviation, and I get a z-score of negative 1.5. Now keep in mind the distribution here that I'm talking about with the computer. It's the distribution of all the prices that people have paid for that particular computer. Jack paid $600, and according to the z-score, that $600 is 1.5 standard deviations to the left of the mean. Now, remember the empirical rule for all mound-shaped distributions, all of the data is within 3 standard deviations of the mean. So 1.5 standard deviations would be somewhere right about here, 1.5 to the left. Keep in mind, though, that the end of the distribution on the left and the end of the distribution on the right is plus and minus 3 standard deviations away from that 675. So I'm just 1.5 standard deviations to the left. So the price that Jack paid for the computer is $600. It appears that there is a certain percentage of people that paid less than that $600. So although Jack did appear that he got a good price compared to most people, there are still some that even got a better price. Now, looking at the camera, if I take the $172 that Jack paid for the camera and find out where it is relative to its average, so I'm going to subtract the average, find out how many standard deviations it is, and it is a negative 3.2 standard deviations. And again, to the left, negative 3.2 standard deviations to the left is, well, that's beyond the left side of that distribution a little bit, because again, the empirical rule says that most all of the data will be within 3 standard deviations. So this $172 is down here on the left, and it appears that really almost all of the people that bought this camera paid more than Jack did. Jack got a very good price. As a matter of fact, he got an outlier price for this camera. Anything beyond 3 standard deviations of the mean in a mound-shaped distribution is a pretty rare piece of data. So a lot of times it's exceptional in some sense. In this case, Jack got the best deal, I think, with the camera. Everybody paid more than Jack did for that camera. And he got a pretty good deal with the computer, though, but there's still a certain percent of people that got even a better price there. Again, the standard deviation formula is a measure of the number of standard deviations a data value is from the mean.